This one's actually in your packet, page 370. This is number 19. So the dimensions we are given here, we've got 0.562 here. This is a 0.312 diameter pin. Let's see, X is right here. This is what we're looking for, is X. We're given the length of this pin, 1.187. We're given this size of 0.562 again. And we're given this dimension here, 0.157. This dimension to the bottom, 0.312. This dimension of 1.780. And this pin, 0.375 diameter. And we're given this angle here. That angle is 54 degrees 32 minutes. 54 degrees 30 minutes, I should say. Now to find X, that distance right there, we know this distance here is 0.562. So if we could just find this distance from here to here, we could then find X. So if we could find this red distance here. To find that, I'm going to start out with this triangle right here in the green. What I know about that triangle is that this length here is 1.187. So I'm going to redraw that triangle. That's a right angle. This is 1.187 here. The question is, what do I have for angles? Well, if I look up here, this has to be a right angle right here, right? And if that's a right angle, that would make a right angle anywhere along that surface. So this would be a right angle up here too. This angle is the 5430. And actually what I can do is I can draw it in here. This is 5430 here. Well, since that's from a horizontal dimension, it's parallel to any other horizontal dimensions. So that means this is parallel to that, which means that this is 5430 here. If that's 5430, that means this angle here has to be the complement of 5430, or 3530. That's just 90 minus 5430. So now I want this bottom side here. That bottom side would be the adjacent side according to that angle. So I have the adjacent, and this is of course the hypotenuse. So I am looking at a cosine. Cosine of theta equals adjacent over hypotenuse. Plug in what I know. Well, my angle is 35 degrees 30 minutes. My adjacent side is what I'm looking for. My hypotenuse is 1.187. So as always here, we're going to put this over 1. And we're going to cross multiply and divide. Well, where we can cross multiply here is the cosine of 3530 times the 1.187. So 0.9664 will go. The 5430 was given. That was right here. So since that's a right angle there, that means this is also 5430. Those are two horizontal dimensions. So if that's 5430, I could slide it over here. This would be 5430. So then 90 minus the 5430 gave me the 3530. Right here. So if we've got horizontal dimensions here, they have to be parallel, right? So with parallel lines, we make equal angles. So this is the 5430. So that has to be the same because those lines are parallel. It's on that same transversal. Well, if I slide this over, this is going to be parallel to that line. So this here is also 5430, which means this one's also 5430. So that's why when I came down here, this was 5430 here. So then this being a right angle, I just subtracted from 90 to get the 3530 for that angle. Okay, so we found that dimension to be 0.9664. That is all the way from here to here. Well, how does that help us? Well, we have to subtract out. Yeah. So we have to subtract out the distance from here to here now. For that color to show up. So from here to here, we have to subtract back out. So how do we find that distance? Well, we're going to break it up into two pieces. I'm going to start out with this piece right here. This triangle. Here's my right angle. So it's right here. So I'm going to pull that triangle out of there. I'll blow it up a little bit, see if that'll work. So that's a right triangle. This angle here is the 5430. And we know this side right here. Because that side, which would be this dimension right here, is the 0.157 up here. So what I basically did is I just made that into a rectangle. What I need is this side here. That's one of the pieces I got to subtract out. I'm going to subtract out that piece, and I'm going to subtract out that piece. We're looking at this one right now. So that's the hypotenuse there. This would be the opposite side is the 0.157. So I have opposite and hypotenuse is sine. So I'm going to plug in sine of 54 degrees 30 minutes equals the opposite side is 0.157 over the hypotenuse is what I'm looking for. Put that over 1, cross multiply and divide. So it's going to be the 0.157 times 1, which is just 0.157, divided by the sine of 54 degrees 30 minutes. Give me 0.1928.
How do you get 0.157?
That's the that's the adjacent. Yeah, right here. Is that dimensions given right here? So that just follows the rectangle, this rectangle. Yeah, it's just a small drawing. I really should have blown that up, but I couldn't make the picture bigger and still get the whole thing on the page. So next, that's this piece right here, which is just 0.1928. So then I need to find this piece here. To find that piece, I'm going to create this triangle. So I'm going to pull that out. In that triangle, I again know that this angle here is the 5430. And I'm given that this height here, this side is 0.312. And I'm looking for this bottom side. According to that angle, that would be the adjacent side. The 0.312 would be the opposite side. So opposite and adjacent would be tangent. Tangent of an angle is equal to opposite over adjacent. I'm going to put in what I know. Come down here. Tangent of 54 degrees, 30 minutes equals 0.312 over adjacent. Put that over 1. Cross multiply and divide. So 1 times 0.312 is just 0.312. Divided by the tangent of 54 degrees, 30 minutes. Gives me 0.2225.
Hold on, so that little triangle, how are you getting that distance from the way you have that triangle?
From this one?
No.
This one.
Yeah.
Let me write this one in here quick first. This distance here, we had the 0.157, right? Nope, here's my right angle.
No, I know that.
Yep.
I'm saying that distance is right.
What I'm looking for is hypotenuse.
But how is your hypotenuse expanding that distance at an angle if you make that little triangle there like that?
Well, I mean, I could rotate it to put the hypotenuse in a different spot. The hypotenuse just has to be the longest side, and it has to be the side opposite the right angle.
Yeah, I just want to see how you put that triangle in there like that.
Oh, up here in the picture?
Yeah.
What I did is I constructed from this spot here, I drew it up to there at a right angle.
Yeah.
So I purposely did it at a right angle. And this is the one that was defined to be the 5430, so that angle has to stay right there. So now that we have those pieces, we can find this distance right here by subtracting. We had the whole thing there was the 0.9664. From that, we're going to subtract the 0.1928, and then we're going to subtract the 0.2225. So I'm going to do this subtraction first. And then here, I get 0.5511. So this is 0.5511 here, which tells us that x which x was this dimension here is the same as this one, is going to be the whole 1.780 minus the 0.562 here. Let's do that subtraction. So at 1.218. And from that, I'm going to subtract the 0.551. I'm going to drop the one. I kept the extra digit in there just to avoid some round off errors, but I'm going to drop it now since that only has 3 decimal places in it. Instead of 5511?
Well, no, I realize that. But
well, I had the whole 1.78.
that's not the whole thing, though.
That goes to here. So I subtracted this to leave me with this piece. Now I'm subtracting the 0.551 to get me back to x.
Oh, it's that. Okay. I see where I didn't know where I was coming from.
Okay.
Why are you putting that triangle on the end like that?
Which one?
The last one on the right.
This one here?
Right, yeah.
Because I had to get this dimension here. Because what I had found, I've got kind of a cluster here right now. So I can get rid of some of my mess.
Didn't you only have to find that 0.551 out of it?
Yeah, I had to find the 0.551, but to get that, I found this distance all the way across here. Then I had to subtract out this piece, which is from that little triangle. Then I used this triangle to subtract out that piece. So I had to find those 2 different pieces to subtract off to get back to it. Yeah, this here, we're going on this whole piece here.
Yeah, from the corner to the straight line.
From here? Which corner are you looking at?
Here.
Nope, you don't know the dimension on that. Well, you could. You could do that, but then there's no way to subtract out that piece. If you go all the way out here, then you can subtract out the piece.
You can make this triangle.
Yeah, that, you don't have the height dimension on that. You don't have any dimensions on that one. That was the only thing. You could probably get to that if you did this triangle right in here and use that triangle to get that height then. You could probably go about it that way. You could probably get there that way. Now, the big question, the $100 question is a question like this ever going to appear on a test or quiz? And this one's probably a step above what I would ever put on a test or quiz for you. Just because it's not doing the calculations. You guys can all do the calculations. It's just seeing the triangles and finding the triangles. Now, there's a certain amount of that I expect you to be able to do. This one's a little bit further than what I would ever expect you guys to be able to pick out on your own. That's one of those that goes into the category of I expect you to be able to follow along when I show you how, but not necessarily sit down and figure it out on your own. But ones that I would expect you to figure out on your own, I want to flip back to one here, number 12, which wasn't part of your homework because it was an even problem.
We do 7 next?
7?
Yep.
Yeah, we can get to 7. So for number 12 here, we have a 1-inch diameter circle on this end, 1.5-inch diameter circle on this end. We are given 0.588 across here. We're given the 0.294 that we're given. That's given so that we know that this is centered on the circles. And we're given this distance here of 1.470. What we are asked to find is center to center in the circles. So we have the distance. If I cut this into a rectangle here, we have the distance from purple line to purple line here. So what we need to find is this distance here and this distance here, and add them to the 1.470. What's that? So now how to find those distances? Well, I can make a triangle right here. Let's look at that triangle.
Why can't you just take half of the diameter and add that?
Because the radius, this gets cut off here. You think about the chord itself would extend out here, so the radius is shorter than the radius. The radius would go past that point. So looking at that triangle there, that green triangle, we know that this distance here is 0.294. The reason is that's half of the 0.588. So from here to here is 0.294. We know this line here is the radius of that circle. So half of the 1.5 is going to be 0.75. This is the radius of the circle. So this is the radius down here. The hypotenuse of the triangle is the radius. So to find this side here, it's just a squared plus b squared equals c squared. Since I have the hypotenuse, it's going to be the 0.750 squared minus 0.294 squared, and then square root. Which is 0.8056. So 0.806 we're going to round it to. What's that? That cannot work, can it? That's got to be short. Oh, I put plus in there instead of minus. Thanks. Good catch. Arrow back there to put in minus there. Yeah, that would have been really bad. So 0.690 it looks like it's coming out to be. So that is 0.690. Yeah, it can't really be longer than the hypotenuse, can it? I'm glad you said something because I was kind of dazed this morning. I would have kept going. I should have caught that. So now we're going to come over here and look at this light brown triangle. In that triangle, this here is still 0.94 or 0.294. This is the radius of that triangle, which is 0.5. So we can just do a squared plus b squared equals c squared again. So the square root of 0.5 squared minus 0.294 squared again. .404. So that means that distance y is equal to the 1.470 plus the 0.690 plus the 0.404. So 2.564 inches is y. Any questions? That one's not so bad. Let's see if I can draw out 7 here. That should be close. So we're given, those are horizontals and verticals there, same there. And we are given this here forms a rectangle with those 4 holes. We are given one inch here. We are given this angle here is 14 degrees. Given 0.75 here. $1.840 here. .562 in both directions there. .638 there. And what's that? Oh, is it not equal, are they? Okay. Wow. I gotta wake up this morning. 0.520, there we go. This is 2.930 here. And what we're asked to find is this angle right here, X. To find that angle, I'm going to work on the assumption that I'm dealing with that triangle. I already know this dimension right here. How do I know it? Well, it's just the 1.638 all the way to here minus the 0.520 here. So that's 1.118. So the real trick is going to be finding this dimension. So we have the 2.93 all the way up here. From here to here is going to be 2.93 minus the 0.562. So I'm going to subtract that 0.562 off. So 2.368. So now what I'm going to do is I'm going to find the dimension from here up to here. So what I'm basically looking at is I'm looking at this triangle right here. So that's going to be a right angle, horizontal and vertical dimensions. So I'm going to pull that out of there. What I have is this here is the 1.840. That's the hypotenuse. This angle here is my 14 degrees. Same as this angle here. So then finding this side, that's going to be the opposite side. And what I have here is the hypotenuse. So that's going to be a sine. So I'll fill in what I know. I know the 14 degrees. I am looking for the opposite side. My hypotenuse is 1.84. So I'm going to cross multiply and divide. So it's the sine of 14 times 1.84 divided by 1. So just the sine of 14 times 1.84. 0.445. So this height right here is 0.445. So what that gives me then is the total height from here down to here is 0.445 plus the 2.368. Adding those two. .813 is that overall height. That would be the height from here all the way down to there. Questions on that so far? That's why I had to find this height, is to get that extra height up to there. So now we've got this piece here, the 0.75 that we can subtract out. I need to find this piece here, so I can subtract it out of the 2.813. So I'm looking at this triangle right here. So in that triangle, I know this is 1.0. That's just that length. And this is 14 degrees. What I'm looking for here is the adjacent side. And the 1 is the hypotenuse. So I have adjacent hypotenuse, which is going to be cosine. So let's fill in what I know. Cosine of 14 degrees equals the adjacent side is what we're looking for over my hypotenuse of 1. Put that over 1, so it's cosine of 14 times 1 divided by 1. So cosine of 14, 0.970. So this height here is 0.970. So from my 2.813 here, I must subtract my 0.970. .843, and then I have to subtract my 0.750. .093 is what I get. So this is 1.093. So now we're at this triangle here. We're ready to find x. Let's pull that out. I know this side is the 1.093. I know the bottom side is 1.118. Here's my angle. This is the opposite side, and this is the adjacent side. I'm looking at a tangent. So we fill in what we know. We do not know the angle. That's x. Opposite side is 1.093. Adjacent side 1.118. We are looking for an angle this time, which means we do an inverse trig function. It's a tangent, so we do an inverse tangent. So angle x is going to equal the inverse tangent 1.093 divided by 1.118. 44.35 degrees. What do you think? Okay. So I want you to spend one more day working on this assignment here. So that's the pages 368 through 371. Tomorrow we will move on. Just so you guys know, Thursday I will not be here. I have to be in meetings all day. So we will start out, we'll only have the first half hour for 35, 40 minutes of class. So we will still have class, but I'll be leaving about 10, 15 minutes early. So I have to be in Shell Lake by 8:45.
I mean, if you don't want to have the class, you don't have to come, you know.
I could just give a quiz.
Yeah, you can just get a quiz.
A couple of heads snapped around when I said that.